All right. Good morning, everybody. Welcome to the Air Transportation Information Exchange Conference, or ATIEC 2023. My name is James Ritchie, and I'm the program manager of the Advanced Concepts branch in the Advanced Concept branch of FAA NextGen. And I will be one of your MCs along with Thomas over the next 3 days. The theme of ATIEC 2023 is deciding with data, leveraging information to make better data-driven choices. Starting today, we'll focus on topics involving emerging and future operations. Tomorrow, we'll move into topics centered around exchange of information. And on Friday, we'll look at advancements underway in emerging technologies. There is great collaborative work being done, and at ATIEC, we're looking to highlight that work, make connections, and facilitate a better understanding of global information exchange in aviation. Without further ado, please let me introduce our distinguished guest, Ms. Jessica Sipniewski, who will be giving opening remarks on behalf of ATIEC partner, the Federal Aviation Administration. Jessica is the Deputy Assistant Administrator for the Federal Aviation Administration's Office of NextGen, where she provides executive leadership, direction, and oversight for modernization of the National Airspace System, as well as scientific research at the William J. Hughes Technical Center in Atlantic City. Her responsibilities include, among many areas, resource planning and stakeholder engagement, including with international organizations. Jessica previously guided the agency's strategic policy, operational, and technical priorities on behalf of the FAA Administrator as the FAA's Chief of Staff, and prior to that, she was Chief of Staff for the Air Traffic Organization, which is the FAA's largest line of business. In 2012 to 2013, Jessica provided technical assistance to the U.S. Senate's Aviation Subcommittee, part of the Commerce, Science, and Transportation Committee, on a temporary assignment. She has worked on NextGen issues in various positions since the program first came to the agency in 2006. Before joining the FAA, she was the communications director for a Surface Transportation Association and a newspaper editor. She holds a bachelor's degree in communications from Elizabethtown College in Pennsylvania. Please join me in welcoming Deputy Administrator for NextGen, Jessica Sipniewski. Thanks.
I got so excited he said my name right that I just wanted to jump up on stage real quick. Good morning, everyone.
Morning.
All right. As James said, on behalf of FAA and Eurocontrol and all of our partners and event planners, welcome to ATIEC 23. It is fabulous to see everybody back here in person, again, after 4 years. So there's a lot of exciting work to do here together today. I'm pretty much a warm-up act for Dennis and Nadine here. So I'm going to spend just a few minutes talking about some of the things that we've accomplished over the past couple of years since we've been apart and set the stage for where we want to go next. So the information revolution is upon us. Information is critically important for many industries, but particularly in aviation. The information revolution demands the information evolution that we're in right now, creating the future of air traffic management. And clearly, we are in a pivotal time in aviation. We're planning for drones, commercial spacecraft launches are going up incredibly right now, and advanced aviation. They're in the skies and sharing the airspace with our traditional operations. We're all witnessing the advances in automation that are happening very quickly: artificial intelligence, machine learning, natural language processing, just to name a few, and they're all coming at us very quickly. Today, air traffic controllers, aircraft operators, flight operations centers, and a variety of other stakeholders all access data from the aircraft, from satellites, from ground systems, from sensors that are transmitting information in near or real time. And how do we continue to transform that data into meaningful information? And how does access to that information help us improve our safety objectives? Well, a fully integrated information environment transforms that data into valuable insights, which enable decision-making and, importantly, improve our safety. So embracing the information revolution within air traffic management provides opportunities for innovation and for performance enhancements in the US and beyond. And with big data, our safety management systems assure real-time safety through continuous monitoring and modeling and verification to detect anomalies in the system and to correct for real-time spikes in risk. And that's certainly something that the FAA is watching for right this moment. The FAA embraces these developments in our vision of the future air traffic system with what we call the infocentric NAS. The Office of NextGen is heavily invested in research, development, testing, and evaluation to accomplish the goals of this future system. So think about our overarching model as research to reality. And let me talk a little bit about how that plays out in real life. We're looking at a system that is interconnected, adaptable, and inclusive of all stakeholders, and data is at the heart of that. And let me be clear, getting to the infocentric NAS is not a single player game. We are collaborating, obviously, with our traditional peers in the aviation industry, but with new industries and new partners that are going to really be essential to getting us to this future. We know that developing an agile infrastructure that supports operations through connected aircraft and data exchange is imperative, and we do have solid work underway today. And let's start with our transatlantic partnership and the ongoing model of collaboration with the Flight Information Exchange model. The FAA, together with Eurocontrol and other air navigation service providers, serve on the FIXM Change Control Board to benefit the global aviation community. This past February, the latest version of FIXM Core was released to the public on an updated website, along with the basic message and the flight and flow information for collaborative environment message applications. That's a mouthful, but it's moving us forward. Along with other exchange models, including AXIM, which is the Aeronautical Information Exchange, IWIXM, the ICAO Meteorological Information Exchange model, and FLOXM, which I always mispronounce and say FLIXM because it should all roll together that way. We are defining that for flow information. We are defining standards and fostering data exchange relationships that will allow for greater global interoperability. You'll hear more about these exchange models during this conference because they're key to our future together. So moving on. To leverage data for meaningful decision-making, we need to demystify information systems, increase access to data because data is power. We need to leverage it. And we have to think holistically to gain new insights. Our research and demonstration projects are providing us with the information needed for innovations in that infocentric NAS. So that's playing out for real right now. A few weeks ago, the FAA, along with Virginia Tech's Mid-Atlantic Aviation Partnership and the New York UAS test site, conducted live flight tests for the UAS traffic management field test. The project demonstrated technology standards, remote ID capabilities, the cybersecurity framework, and other advances in UAS traffic management that support small drone operations. There is an incredible desire to get these up and running here, and this was an opportunity to see how all this would work together. It demonstrated deconflicting drones using third-party services, and it showed how those third-party services can interact with each other. This is the future, and it's starting today. Earlier this month, Acting FAA Administrator Nolan unveiled the FAA's updated concept of operations for urban air mobility at the Wall Street Journal's Future of Everything conference in New York City. We expect that the global air taxi market to debut in cities around the world very soon. For example, the company that operates airports in Paris has announced it plans to support air taxi services for next year's Summer Olympics and Paralympic Games. Are we ready for that? We need to be, and the FAA is preparing for these new operations using more connected aircraft from day one, and that will eventually require new traffic management concepts. We've been working closely together with the manufacturers of these eVTOL technologies, which will be the first air taxis in this class here. And we've been in partnership with our colleagues in air traffic, the Office of Aviation Safety, the Office of Airports, and many other parts of the agency to establish the advanced air mobility ecosystem that will enable those aircraft to operate at one or more test sites, key sites, by 2028. And let me just pause for a second here and say that we say 2028 because 5 years is a lot to accomplish, incorporating a whole new type of operation into the NAS. But it's fully our expectation that some of them will begin much before that. That's the intent of those operators. And the FAA's commitment is to be there to support them when they want to become flying and are able to flying. So our expectation is that we will be with them when they choose the location that they would like to go to. And we'll learn building blocks so that in 5 years' time, we can allow those operations at scale perhaps with a third-party service provider helping to deconflict those aircraft. It's a very exciting time to be in aviation. We make it a priority to work with our international counterparts because aviation is truly a global system. We learn from each other, we work together, and the information revolution will require an even tighter synergy for success. As the FAA expands TBO operations domestically, we are also demonstrating the benefits of TBO across flight information regions and countries. So just next week, we're working with aviation authorities in Japan, Thailand, and Singapore to conduct a multi-regional TBO live flight demonstration. We will fly between Seattle and Tokyo, Tokyo and Singapore, overflying Thailand, Singapore to Bangkok, and Bangkok to Seattle. Along the way, the flights will explore different scenarios and use cases with the connected aircraft concept. And that demonstration will also be an opportunity for us to gain feedback and refinement on Flotsam. As I said earlier, you're seeing research to reality in real time. So I want to thank everyone who is here to focus on that future together. We have a robust program today and for the next 3 days that will focus on these concepts of the infocentric NAS here for the US and for the global community as well. James gave us a highlight of some of those activities, but I want to go off script. I know Tony isn't here, so I'm just going to close my book on my script and just kind of give you a few of my own thoughts here for a moment. It's just really been my reflection over the past couple of years working at the FAA, how lucky we are to have such a clear and defined mission. All of us here in aviation are here to provide for the safety of people as they connect with the people and the places and the things that are important to them. It is a great gift to have such clarity of purpose in our work. And what I would say for us in this room here, our purpose is amazing in that we get to create the future, which is safe and efficient and sophisticated. And I got to tell you, that's not a bad day in the office. So I invite all of you to take advantage of the time that we have together in person for the first time in 4 years, to really listen and learn and share and collaborate. This is a great moment in time for all of us, and I cannot wait to see what we can accomplish together. So thank you for your time, and back over to Jim.
All right, thank you so much, Jessica. So next, giving opening remarks on behalf of ATIEC partner Eurocontrol is our distinguished guest, Mr. Dennis Hart. Dennis Hart is the head of the Information and Cyber Unit, IAC, of Eurocontrol. The unit is responsible for information management, cyber and information domain, specific developments, and associated common services. These common services managed by Eurocontrol IAC include the European Aeronautical Services Database, or the EAD, the EATM cert, and the new PENS Management Unit. Dennis has extensive experience in topics related to information management for aviation and was in the role of one of core contributors in the development of the CSAR work package on information management. He is now intensively engaged in the deployment of SWIM, including specific aeronautical information related application such as Digital NOTAM and the successor of EAD as part of the integrated replacement of network manager systems. Dennis is a member of various ICAO working groups, including the ICAO Information Management Panel, and is working in its working group on aeronautical information management. He and his team support, amongst other things, SWIM, AIM, MET, and FFICE related activities in the European region and at a global level by providing support, relevant guidance, material, and relevant specifications to meet stakeholder needs. Please join me in welcoming Dennis.
Thank you, James. Thank you, Jessica, for the opening words. And let me continue basically by indicating that I'm really honored to be here to welcome you all to the Air Transport Information Exchange Conference. And that is, like Jessica already indicated, an exciting time for the aviation industry as we continue to advance our understanding of the technology and practices that are driving the future of air travel. But let's stop here, because that is basically what ChatGPT proposed to me as my opening speech. So again, the request that basically was given to me to also get a little bit of an opening aspect to this ATIEC 2023. ChatGPT was pretty good in, again, suggesting what these opening words could be. So for me, it is a clear example of basically the unleashed power of data. So this is, again, only one example where it basically perfectly helps me in doing my job, doing opening speeches. But again, it is still also a little bit worrying sometimes, because we need to bring all these needs, possibilities, but also the concerns relating to unleashing the power of data together. And that is, I think, where the ATIEC is extremely helpful. Because again, the needs are pretty clear. What you see here on the graph are the predictions when it comes to European traffic. So yes, we had a little bit of a dip during the COVID crisis, but when it comes to the various predictions, the various scenarios, we are quickly returning to the travel levels around 2019. And again, the growth is still predicted to go on. Of course, it also needs to be mixed and matched with the sustainability needs that we all have. For instance, one of the elements that you see here on the slides is related to the CO2 emissions. Again, as a global community, we also have the obligation to tackle this aspect of aviation. And again, this is from a needs perspective very clear, and where, again, data could help us. But again, we should also not walk away for the various concerns we have. And one of the big concerns, of course, with unleashing the data is that we also become more and more vulnerable for cyber-related concerns. And here on the slide, you see a couple of indices when it comes to the cyber concerns that we identified for the European environment. And it is probably not that different for other environments around the globe when it comes to aviation. For the moment, I need to say that we are pretty lucky from an operational point of view. And I already apologize myself for some of the airlines sitting, or representatives of airlines sitting in the room, because the attack surfaces were basically more and more focused on getting financial gains out of the cyber attacks. So it was not basically focused on getting the operations down. It was more related to, okay, getting money out of ticketing systems and what have you. But also that is quickly changing, because, for instance, we as Eurocontrol were part of a DDoS attack for 100 days a couple of weeks ago, because we were associated with one of our member states that is in war, Ukraine. So that basically started to also impact operations. I would not say big time, because at the end of the day, we were pretty well protected. But you see also there that landscapes slowly moving into also the cyber criminals, let's call them like that, in that way, moving their attention to also hampering the operations and not only going for, again, the financial gains out of their criminal activities. Of course, there are also a number of elements where we still need to work on the cost efficiency of the whole air transport system. Also, the resource constraints are more and more visible, at least in Europe, where we don't find the skilled labor anymore to support us. And that is where automatically also automation needs and AI needs kick in, but again, linked to also some of the concerns that come with it as well. Last but not least, to also help, and some people will not agree with me that it is of help. In Europe, we also have now a clear regulatory environment that basically pushes for the implementation of swim services. So by the end of 25, we in Europe need to have FFIs, AIS, met-related swim services in place, in operations, both on the production side, or the producer side, and on the consumer side. So again, all of this makes, again, the ATIEC extremely valuable and extremely needed, because the need for air transport information exchange, which was always at the heart of the ATIEC, and it's even in the title of the ATIEC, has never been greater. So again, to have the discussions over the coming 3 days on system-wide information management, on information security, on the various information domains with the information services, and also going a step deeper when it comes to the exchange models, AXM, FIXM, and IWIXM. I use the European names for it. So again, it's the need for it has never been greater, and especially when it comes to the regulatory obligation that we are faced with in Europe. Again, we still have some challenges to overcome, and again, an ATIEC is of help. So the ones in the audience that know me, I'm a very lazy person, so I will go back to ChatGPT. So again, and it was perfect. It was really perfect. So we need to work together as an industry. We need to share our knowledge and expertise, to learn from each other's successes and failures, and to collaborate in order to find solutions to the challenges we face. Again, I will stop here, but this conference will really be an exciting and productive event. And we need to more work together, better work together, and learn from each other to make all these things happen. Because again, data, like what Jessica indicated, is at the core of what we need to do, or what we need to establish in terms of the various needs that are on the table for the wider air transport system. So thank you for joining us, me, and from my side, let's get started with the ATIEC.
All right. So before we get into our keynote address, we actually will be using a Q&A platform called Slido. We will not have a slide up, but if you go to Slido, SLIDO.com, or download the app, you'll be able to enter in our event code, which is 1321088. And what that'll do is you can connect to us, and we'll have a person moderating the questions, and we'll be using it throughout the day. So our next keynote will have a Q&A session as a part of it. So we'll be utilizing that tool to solicit questions and have Nadine answer those questions live. And then as we continue throughout the day, continue logging in with that same event code, which is 1321088. So on that note, I am pleased to welcome Dr. Nadine Alame to the stage to give the ATIEC keynote address. Nadine is the CEO of the Open Geospatial Consortium, or OGC, a global not-for-profit membership organization hosting the largest collective problem-solving community of experts, making geospatial/location information findable, accessible, interoperable, and reusable, or FAIR, via open standards, innovations, and partnerships. Dr. Alame spent her career applying open mapping/geospatial standards in multiple domains, including aviation, Earth observations, public safety, and defense. Prior to OGC, her industry roles included Chief Architect for Innovation at Northrop Grumman, CEO of Aviation Data Startup, and Senior Advisor to NASA. She is a champion of interoperability and collaboration at scale in the expanding geospatial ecosystem, and a passionate cheerleader for the value that geospatial can bring to new domains like digital twins, gaming, and the metaverse. She is an appointed member of the U.S. National Geospatial Advisory Committee, NGAC, and sits on the board of the UN Committee of Experts on Global Geospatial Information Management, UNGGIM, private sector network. She was awarded the 2022 Geospatial World Diversity Champion Award and the 2019 Geomatics Canada Diversity Leadership Award. She has a PhD and 2 MS degrees from MIT in the field of Geographic Information Systems, or GIS. Please welcome me in welcoming Nadine.
Good morning, ATIEC. It's been too long. It's so good to be here. I'm gonna need my drink. It's my fake Frappuccino, nothing. Don't be alarmed. So it's really, really good to be here. Thank you for the invitation. Thank you for the warm up, Jessica and Dennis. Really appreciate it. Thank you for the invite from FAA and Eurocontrol. I see Eddie. I don't know if Hubert is here, but it's good to be back with friends. At the same time, I have to admit that I don't think I've kept up with you over the last 5 years, so I'm here also to learn. I've titled this keynote From Data to Decisions, and maybe I was inspired by Tina Turner's passing last week. What's love got to do with it? So what's geospatial got to do with it? Because I don't know if anybody here is wondering why is a geospatial geek doing the keynote for an air transportation information exchange event. I'm not gonna ask you to raise your hands if you're wondering, but I actually thought about this and I have 2 reasons. One, for some of us, everything is geospatial. Because everything eventually happens in time and space on this earth and actually in this universe, because we're expanding right now the geo part to space. We're actually working with NGA, with NASA on the lunar missions. So we talk about coordinate reference systems on Earth, we're talking coordinate reference systems on Mars, on the moon, and everything in between. So when we're talking about, commercial space, that's going to be very, very critical. So it's very, very exciting times. Geospatial to us, geospatial geeks, is a connecting concept. Eventually, when we're talking about building digital twins of cities, of towns, of countries, of the world, of the universe, the location, the space, right, the geospatial sort of connects everything. So I do see geospatial everywhere, and I'm not ashamed to admit it. But the other reason that I think geospatial matters is, believe it or not, it's everywhere in aviation, and we've worked with you over the years, so you're no strangers. I hope you realize that AXM actually has the geography markup language in it, GML. Yes. And I got this slide, I Googled, I found this slide from 2007 that says AXM is GML. So it's pretty cute. Moving on, in FIXM, we didn't use the geography markup language, but FIXM has positions, right? Everywhere, coordinates. UTM has positions as well. So it's all eventually including geographical positions. Speaking of UTM, this community has used a variation of JSON. So not GeoJSON, but JSON with some, again, coordinate reference system and geographic position for the positions of those drones, again, going back to position, location, geospatial. And even weather, or most importantly, weather, because weather is one of the biggest disruptors still of air traffic. If we look at CSS weather, for example, it has geospatial all over it, because each one of these web services that are sharing the weather information are built on, in this case, OGC standards, international standards. So really, it's not just me who sees geospatial everywhere. I think you do too. You've got it in every one of these exchange models. So again, great. Here's the other reason I think I'm here, because this conference is about data. And I think with geospatial, we've been dealing with big data since before they called it big data. Right? We've been dealing with Earth observation and remotely sensed information, seriously for more than 50 years. And we live in exciting times. So these days we're collecting data from space. I just showed this cute video to my 5th grader, my son, career day. We've got so many satellites orbiting the Earth. 27% of them are actually Earth observation satellites. It is thousands of terabytes per day that we're getting on our Earth, right, alone, that we're trying to fuse, to integrate, to analyze, to apply AI. I mean, no wonder AI is exploding, because nobody with a regular eye can deal with all of this. It's fascinating. But it's not the only source of data. Here on Earth, with the sensors, the Internet of Things, and again, I Googled, I found this data from Splunk, but there are, also many statistics on, essentially, we live in a society, they call it a datafication society. Everything you do is being captured, and the location is being captured. We've got a lot of data on, cars moving, people moving, planes moving, assets moving, everything is moving. That's all sensor data. Also, terabytes, zettabytes of information. And it's being applied for health, it's being applied for agriculture, for retail, for defense, I can go on. And yes, there's a dark side to all of this that we won't get into in this talk. And here's the most amazing thing to me is we're doing amazing things with this data. So here's one example from one OGC member, Hexagon. So from, for example, this Earth observation data, we're applying AI and machine learning to extract features. So Dennis mentioned Ukraine. So this methodology has been used in Ukraine to detect in real time the damaged buildings, the damaged road. We can do that with AI right now. We can extract features, so buildings, roads, trees, individual trees, and then you connect them to the tree database. That's definitely not my area of expertise. And then you're getting, when we talk about digital twins, then you can get to simulate all sorts of things. What is it? The wind pattern in New York City on any given day? We can do that with real data, which is the most exciting. I tell them, this is not Hollywood. Although we are also talking to Hollywood. So believe it or not, we used to be, Esri and Hexagon and Trimble and TomTom. We moved, I think 5 years ago, we were talking more to AWS and Google and Apple and Microsoft. And now I'm like the coolest person in my house because I get to talk to the CTO of Roblox, of Epic Games, Pixar, because they want this data. One, they want the data, and two, they have their own models of the data. And what we're trying to do these days, if we want to build these digital twins for the modeling and simulation of the world, we have to also sort of fuse or integrate or interoperate across these models. So think about it. We have our geospatial models of water, of soil. You have the AXM, the WIXM, the FIXM, every AXM for every domain. But there's a whole construction industry out there. There's a whole pipeline industry, and they have their models. And the Hollywood people, I call them the Pixars, they have this universal scene descriptor. That's what you see in the movies, all these, how they create all these environments with synthetic data. We're trying to bring everything together. That's the ultimate interoperability. Ultimate interoperability, but this is painful. I talk about the latest and greatest, technologies all over the world. But then I also tell my sons that people are still dying from the simplest things: flooding, fires, viruses, right? So we could think we're invincible, but eventually we're dying of the basic elements, right? And part of it is flooding, wildfires, drought. It's occurring more and more. I won't, bother you with the statistics. It's happening not just in the developing world, it's happening in the developed world. So these are examples from Vancouver and Europe. So it cannot get any more sophisticated, I think, than this. You talk about another simple example. Again, this is, I'm trying to just understand the contrast between the amazing technology and all the data and then reality. When they dig on your street, on my street, seriously, and then the water pipe bursts, because every time they don't know where the water pipe is and where the fiber and where the electricity, over and over, billions of dollars. Also, you can Google it, billions of dollars in London, in New York, in Singapore, right? So once again, you ask yourself, so what is missing here? She just was saying everything is great. We have technology, we have data. So to me, it's coming back to, yes, we have tons of data. We have tons of information. One of the problems is when you need that information, you can't find it because we're drowning in a lot of information. And when you find it, believe it or not, it's still not accessible. You still have to figure out how to get it and which format and which model and which version of the model and what system. And then it's not interoperable. So you want to combine it with, what do they say? When data meets data, you get magic, right? So you want to combine it mostly with somebody else's data. Good luck. Again, 2023, we still have the same issues. And the reusable, I always say we reuse, but we hack it all the time. It could be way more reusable. So that's what we're trying to do. I think that's the gist of it at the end of the day. Level 0, this is before you get any of the sophisticated stuff. Level 0, data has to be fair, findable, accessible, interoperable, and reusable. So we're trying to do this in OGC, in case you don't know who we are, the Open Geospatial Consortium. The most amazing thing about this community is that now we're at our largest number of members ever in OGC. And it shouldn't be a surprise because everything is geospatial, right? So more people are realizing the benefit of location. That's why we're attracting, the Walmarts and, the retailers and the data scientists and so on, organizations. No surprise, FAA, Eurocontrol, Airbus, etc. They're all great members of OGC. My favorite part of the growth of OGC in the last 5 years is that it used to be third government, third industry, third academia for 25 years until 5 years ago. Industry, right? And what? .ai, .ai, .ai. This company.ai, that company.ai. So startups, between the investment and the data being available, we're having this whole essentially ecosystem that's supporting a whole new market, right? An expansion of startups and businesses that are doing data mining, analysis and so on. So it's really, really amazing. So it's becoming, how do we do this? How do we enable an ecosystem that's bigger than any of us? Because you can't just be on the phone with everybody, right? So what we're trying to do is to lower the barriers. There's a lot of data. Let's lower the barriers such that the non-geeks can also use this data, right? So it's not, oh, we're the geospatial community, we're so cool. No, it's the opposite. We're going to lower it so that everybody can use this without even thinking that they're using geospatial, right? So that would be success. And what we're doing is, at the end of the day, you want data to meet data, you want systems to meet systems, you're gonna need some standards, some glues, except that we found out that you actually need way more than just the standards. You need the standards. You also need the best practices. That's where the community comes in. You need readiness guides. How do I do this? Tell me, how do I deploy a workflow for flooding? Don't tell me there's a lot of data on floods everywhere and good luck to you, right? Why do we have to reinvent the wheel? Developer resources are becoming super important, right? We want our developers to Google, to find, to use it and not have to read. Has anybody read the GML? Eddie, don't answer. You don't have to read 500 pages of complex information. So we're simplifying the complexity. Demonstrators, so on. And there's this concept of definition server that we can get into the break. But this idea we're trying to build where imagine if we have all the models of everything in this world broken down into the small building blocks, and we can actually house them and relate them semantically in one place, so that you can come and build a digital twin, get a little bit of a runway here and a little bit of tree from a totally different community, and everything is actually linked in the back because we've worked across disciplines to actually link it together. So it's a dream, it's crazy, but we're trying to do it. So lowering the barriers, I'll share with you some of those things when we talk about data and decisions with data. We've been pushing on APIs, open APIs. So it turns out, right, we want any developer, same thing is gonna happen with Swim, right? So we have to make it easier to integrate this data with any other type of data. That's been the push on open APIs. So people can use maps and tiles and routing and coverages and features just like this as an open API. We've done, I think we haven't done, our members have done an amazing job with weather and open APIs. So the National Weather Service and the UK Met Office got together with the rest of the community, and they have an OGC environmental data retrieval, EDR, which applies to weather. Essentially, you can slice weather according to a corridor or a flight path or anything you like, also using open APIs. Again, let's lower that barrier such that it's not heavy lifting just to use some data from the National Weather Service, right? Because usually your mission is not, please go get data from the National Weather Service. Your mission is, help me solve the problem, help me divert the flights, help me plan for how many flights. So you want to get the basic out of the way. GeoJSON, I don't know if you've heard of it, same deal. Want to make it easier. So it turns out GeoJSON is great if you're on a trail or if you're navigating in a car. Turns out for the underground infrastructure, for example, they need way more. So this is a great example of, we want to make the data easier to access and to manipulate, but we want to maintain the accuracy and the precision and the seriousness of the data, right? So in this case, the community is developing this essentially super model around GeoJSON that works with various coordinate reference systems and also types of geometries. And last but not least, have you heard of the cloud? Yes, so the cloud is here, and it's here big time. So there's this big push to talk about lowering the barriers on cloud native geospatial standards. So what's the idea here? The idea is you don't have to, we have to break this model of, we have to download all this data and download all this other data and then run all of our processes. So in this case, keep the data on the cloud. Cloud natively, the formats that we'll use will help me just go get the piece that I want. I can even do the processing on the cloud. So we save a lot. Again, lowering the barriers. I don't even have to have a huge software on my laptop anymore, right? Because I can actually deploy things on the cloud. So this is super disruptive. And, you talk about scale, right? Because a lot of data is on the cloud. So sooner or later, all of this is coming to Swim, right? The APIs, the new JSON, the cloud native formats, sooner or later, it's coming to this community. And I would be interested to see where on the journey you are. So it fascinates me how we're moving on the basic interoperability, sort of spectrum. So we're talking APIs and cloud native, but also we're seeing this amazing shift that everything is in 3D now and everybody expects things in 3D. So a big push on 3D modeling, 3D portrayal, 3D APIs, and even higher. And I think I love that this community started there, the models, right? Because we need to interoperate at the models, cities, airports, indoor infrastructure, water, soil, air, you name it. And we say in OGC that climate change or climate understanding is the ultimate use case for interoperability. So if we want to solve and if we want to address, or if we want to just understand what's happening with our climate, you're going to have to integrate across all these models, interoperability. And it goes up, there's a whole new concept that's not really new of analysis ready data. Don't just dump the data on me and say, good luck to you. We are actually defining criteria for analysis ready data. So you talk about data quality and metadata and data provenance, just tell me so I can use this data from this supplier and this data from that supplier. They're both analysis ready data and I can move on. I don't have to curate, I don't have to clean, I don't have to pre-process. And all the way to, digital twins and metaverse, not the Facebook sexy stuff, metaverse, not sexy, I don't know, but metaverse as your, the ultimate 4-dimensional, fully immersive environment that has all this data from sensors, from Earth, from space. So a glimpse into the future before I wrap up. This would resonate with the geeks here who've been with us on the journey of the Axum, Wixum, Fixum. PubSub is back. Does anybody understand what I'm talking about? Yes, so we need to, it's not just, I'm gonna go get the data, it's just, please let me know when the data that I want is there, right? So it's interesting. It's a problem not unique to aviation, but it came really loud from this community. We've worked on it, and now it's back even louder. And in this case, it's been driven by the weather data. So you can see here from, the World Area Forecast System, ICAO has a requirement. You guys are the expert, but that's interesting. And please look at the time scale of now developing standards. It doesn't take 10 years anymore. It cannot take 10 years anymore. It has to be quick. So I call it, we're developing standards at the pace of innovation these days, at the pace of technology. And what if I told you that we're trying to bubble up everything sensor, space, air, land, sea, cyber, you name it, underground? Why do we have tasking systems that are different? And if we want to interoperate, in this case, I just came back from the GeoInt Symposium. So defense and intelligence, you want to be able to task whatever you can task for any mission that you need. So how about one standard? It's called connected systems. That's the terminology that NIST is using. And that's embracing all sensors because they're all sensors. They're different, but they're all sensors at the end of the day. So I think that was becoming, for UTM. And GeoAI. So we call it GeoAI, which is, applying all sorts of patterns related to space. But now, I love this. This is from one of our members, CartoDB. He gave a keynote last week at a data science event. And I like that AI is the new UI, right? So instead of processing and whatever, we're all going to say, tell me, just tell me what I need to know. That's why you need to trust the data. That's why, you need to know where the data came from. That's why you need to have all the provenance and all the chain. So once again, we're hiding the complexity. The example that they showed here is, instead of spatial SQL, it's all natural language, show me all the Starbucks in California. And then you can say, show me all the competitors. I've seen a demonstration a month ago from one of our other members, Planet Labs. So they collect data from space, and they're building Earth GPT. So you don't just say, give me the Landsat data. You say, where should I go if my house floods? And everything in the background is being done for you. The data sets, the processing, the visualization. This is not magic. This is standards and interoperability to get there. So I think this is the glimpse to the future. And you talk about future, and I'll end with this. This is the digital twin, the synthetic data. So what we're doing with this data, so this is from a military action modeling and simulation conference that I was at about a month ago. We're blurring the lines between real data and synthetic data. I mean, this is not just for geospatial data. We're actually blurring the lines for everything, right? For fake news, for voices, for imagery, for videos. But this is pretty powerful because this is your real data, and the user can pick any mountain on Earth and glide. It's an interesting application of having a lot of data. And you can pick the weather because we collect it all, so why not? This is another cool thing. You talk about digital twins from our member Presages, they're up in Canada. So all of this digital twin was created via AI from space and from sensors. So they're recreating entire cities, and then they add the conditions. So in this case, the flooding, they measure it. They track the cars. So even the cars, the sensors, the traffic cameras are all being integrated into this modeling and simulation environment. And then you can play all sorts of scenarios, right? Where should I escape? Where should I plan? What should I do, etc. So again, think about that in the concept of air traffic control. And last but not least, our association with AWS and this small business called Duality. So this was revealed at the reInvent show back, I think, a few months ago. So everything you see is digital twin, as in this is the real data. This is not Hollywood Spider-Man. This is the real data, the real buildings, the real traffic signs, the real roads. But what AWS is doing here is adding the human element. So we're simulating the human behavior at scale, right? At city scale. And this is, again, you talk about, I tell them one of the best demonstration I've seen recently, and I felt like I was in an Avenger movie. NVIDIA, one of our members, had on a screen 30 Earths, right? And every Earth was running a different climate model. Right? So imagine what we can do when we get to that level of sophistication. And we have the AI, we have the computing, right? We have the data. We just need a way to scale the connectivity of the data. And that's the interoperability, right? The information sharing. So no one can do it alone. That's my, I realize this every day. Nobody can do it alone. Nobody can make all this data findable, accessible, interoperable, reusable, especially to the people who are not the geeks who created it, right? That's when I call, geospatial. We're trying to get the non-geospatial people to use it. I don't know, air transportation people, right? You're trying to have the non-air transportation geeks also use your data for other purposes, right? So we can't do it alone. That's why we need standards, we need best practices, technical resources. But as I get older, I realize that you cannot do the technical stuff without the human, the organizational. So I appreciated, Dennis speaking about even governance and requirements and policy. So the cross-discipline is so important. We learn so much just by looking at what other domains are doing. How are they optimizing? What kind of data? What kind of tools? What kind of software? And what kind of businesses they're working with? I mean, even the concept of system integrator is also changing and being disrupted. Partnerships, everything that you've seen is public-private partnership. I know it's now the latest buzzword, but you cannot get at this scale, right? And aviation is a great example, and education. And my last thing is, for some reason, a lot of people, when they see all of this, they get excited and they think it's magic. And I have to say, it's not magic. I think that's why you're here. It's actually hard work, making complex things simple for other people to use them, making data usable, findable, accessible, and interoperable for any application so that it can plug in for something even bigger and gives you all the possibilities that you want is not magic. It's actually a big investment. So that's what I would call for. I would say, with everything going on, we need more investment in what I call collective R&D. We need to be experimenting more together. on these scenarios that maybe are just air traffic and air transportation, but also let's see how it works in that same context with the commercial space, with other elements of UTM, with disasters, with digital twins, and eventually with the whole Earth. Because, you've heard it in the morning and the opening statements, we're part of a big, big ecosystem. So thank you for the opportunity, Geospatial Geek, sharing with you everything that's happening out there. And I'm really looking forward. Down one more. All right. Oh, that's the questions. Oh, I was like, what is this? ChatGPT. So thank you again for actually investing your time in being here and in your commitment, I think, to this working together for interoperability, for standardization, for information exchange, which are not the goal. The goal is solving the problems. The goal is better operations. The goals are safety. And I think this is where we need to get better at this foundation work so that the rest of you, which is the larger portion of the community, can just get on with their lives. Yes? So what non-aviation exchange models should the aviation engineering community be tracking? Facilities, IT networks? Ooh, facilities is huge, huge. So there's a huge push to actually bridge the construction community. So think about it, construction, because then you have the buildings information, not just from the outside. So from Earth observation or remotely sensed data, we can get the outsides of the buildings. That's great, yes? But the insides, the construction industry has it all, right? So you talk about, evacuating people from a building. You want to know how many rooms, how many stairs, how do the rooms connect, how many people they hold, all this data. There's a big, big push to actually, sort of bridge, that world with the geospatial world. I think there's a lot. I mean, I was recently, NASA is doing plenty, I think, on just facilities and, information systems infrastructure. I can think of, sensors and networks. We see a lot of the natural geography, right? Water, hydrology, and soil and pipelines, underground infrastructure, again and again. Yes, we don't have a model for underground infrastructure. You would think 2023, let's just do this. We don't have a model, I learned recently, for the road network, like an international standard for road networks. So imagine all these autonomous cars, companies, they're actually, when they build their software in these cars, they actually have to do it differently in every country because we don't have an international standard. And the organizations that are excelling at using these types of advanced simulation for training. So I've seen two, actually three, I would say. So defense and intelligence, right? So military simulations, very, very advanced, right? Because they're trying to train the soldiers before they even get to the compound. You put on these goggles and you are there. You are there in a way that you actually know how heavy the doorknob is, right? When we talk about digital twins, it's digital twins of everything. So they practice literally everything and every possible combination. We're doing it a lot for disasters because they're coming at a high rate. They're doubling in frequency and they're doubling in cost. And it's happening, even the bit in between disasters is actually also shrinking. So there are all these statistics that are pretty scary. So we're working, for instance, with, say, state senators who are interested to know what happens if I get twice the number of hurricanes in my state next year. Seriously, because that's not a crazy thought. Right? So you come in, and that's the beauty of, again, bridging all this information and digital twins, because then the senator, once again, where we have a panel later about the user, right? Who's not the expert, but you go in and so you see the hurricane and you see the water damage, and then you also see the dollar signs. This bridge went out, and if you're gonna rebuild it, it's gonna take you this long and it's gonna cost you this much. Why? Because all this data is there. It's all there, and we can actually pull it together. Last but not least, the advanced simulations for climate. Again, the ultimate use case, and it's only beginning. And you talk about migration patterns in the future. I mean, it's mind-boggling, honestly. Maybe space. Space is also, I mean, you know, some of these applications that we're seeing in space, so you're going to see more and more, which I don't know if this is good or bad, but it's all falling under, you know, we're trying to figure out what happens to simulation. None of it would happen without data. We have a lot. I'll end with one last thing, and maybe we can cover it in our panel later. One thing made me think on an event recently when I think the keynote speaker said, everybody says data is the new oil, data is the new oil. I am beginning to think that data is the new plastic. We collect and we throw and we collect again, and you collect it and you collect the same data, and it's everywhere, and it's just more and more resources. So something to think about. I think it's not about the data. We got that. Let's focus on what we do with the data. So thank you again.
All right. So thank you, Nadine. And thank you for everyone who tuned in during our live stream of the opening remarks and the keynote speaker.